Hi there, my name is Yifei, and I am a PhD student from McGill University. And today I'm going to bring a work I worked with Sarah from Cohere and Professor Lily as my supervisor. So this work is called Mimic, which integrates diverse personality traits for better game testing using large language model. And before talking about this, I want to talk about a little bit about the current world. So currently, automatic game testing has been widely using agent-based testing techniques, where they just directly put the agent inside the game to let them play test the game automatically. And some of the agents they build using machine learning, basically reinforcement learning or imitation learning. And some of the others, they use large language models as the planner to help the agent inside the game to decide what to do next. And both of them, they suffer the same kind of limitations. They solve problems with homogeneous and repetitive solutions when facing to the similar scenarios. And this is because that a lot of researchers or developers, they actually want to aim for the optimized solutions all the time. And that makes the agents to be a little bit different from reality. Because in the real world, actually different players use different strategies for such situations. For example, a player in the game might run away from a ghost, while the others might just go combat with them. And from literature, we found that such distinct strategies from different players are actually shaped by their personalities. As a result, we propose Mimic, which is an LLM-based agent that integrates diverse personality traits. And by doing that, we enhance the diversity in problem-solving strategies under similar scenarios, which helps the Mimic to cover more in-game interactions. Here's an overview of our tool. So we have four components: LLM Planner, LLM Executor, Summarizer, and Memory System. And then at the planner, we let the LLM to generate the plan, and then we send to the executor to execute the plan. Basically, they just create the scripts and let the agent to run automatically inside the game under test. And then we collected all the information and sent them to an LM for summarizing what happened and to give some critics about what to improve or some suggestion for the next move. And we store all of them as a memory inside the database because we want to simulate how the memories, how the experience actually affect the decision-making process of the human. So we have the memory system, and after that, we send the related and preferred memories to the LM planner for the next iteration of the loop, so that the plan can use them as a guide. And such loop will iterate again and again until an in-game goal or time budget has been reached. And I will go deeper a little bit about the planner for here. So this one is the most important part of our work. And basically, what we do, first of all, is we collected 7 personalities from existing literature and combined with the in-game environment, we set them to an LM and let the LM to generate the plan. And the plan can be usually defined into 2 parts: a long-term goal and the sub-goals that used to combine and solve that long-term goal. And we have the planner in 2 fashion, one bottom-up fashion and top-down planner. And in the bottom-up planner, we let the planner to generate the next immediate goals every single time when the agent needs the guide from the LM. And then we are expecting them to eventually finish the long-term goal after completing all the immediate goals that's created by the bottom-up planner. And in the top-down planner, we do it in a reverse way. We let them to produce more higher level long-term goals, and then we divide them into little sub-goals that let the agent to follow one by one until the long-term goal has been reached. And this kind of different fashions will be switched in between iteratively according to the diversity of the plans so that we can keep the diversity of the plan in a really higher level. And we call this as a hybrid planner. And then we deploy our mimicking to 3 different games, 2 open source game and 1 closed source game. And I will talk about the closed source game as an example for here, which is Minecraft. an open world game that's let the player to do a lot of stuff and basically whatever they want inside the game and to explore what's happening inside the game. And we selected a baseline. It's called Outside, a sort of LLM based agent in Minecraft. To compare with the performance, with the Mimic, we show the task completion performance by giving 8 different tasks to both of the agents, and both of the agents get the same time budget. And we found that Mimic achieve 100% of success rate for all of the tasks, where the SOTA 2 failed in 3 of the tasks, and 2 of them actually have much lower success rate, which is under 50%. And after this, we selected one task called Obtain 1 Diamond, which is the most complex task among all of the tasks, to show the interaction diversity of the Mimic and the SOTA 2. And this task is having 11 mandatory subgoals and hundreds of different solutions. And then we collected the average distinct items and average distinct actions interacted by the Mimic and the SOTA 2 during the solutions. And in the matrix, we can find out that Mimic actually have higher values in both of the matrix, which shows that the Mimic actually having the higher interaction diversity than the SOTA 2. To give you a more concrete idea about what is happening for different agents with different personalities, we give 3 examples here. So for the aggressive agent of Mimic, 15% of its actions are combat, while the others only have the 2% of combat actions. And at the same time, cautious agents, they avoid combat entirely, and it's the only one that crafts the torches before mining deeper for the diamond for safety. While the adrenaline-seeking agents, they actively craft swords and explores high-risk areas to encounter challenges inside the game. And to be noticed, the SOTA performs none of the listed actions, including the combat actions, showing that our agents can really do their works by following what the personality has been provided, and at the same time they show more diverse solutions during the solving time of the problems. In conclusions, inspired by the diverse strategies of human players, we integrate personality traits into an LLM-based gaming agent called Mimic, which actually outperforms the SOTA tools in terms of both the interaction diversity and the performance in the task completion. And we can say that such personality-driven automation can also be applied to other domains. For the domains where the navigation paths are pretty important and it might diverse depending on the different personalities that the human have. For example, the user interface, testing, or human-computer interactions. And thank you for listening. And if you are interested about our project, you can always go visit our website by scanning this QR code here. And you are always welcome.